Oh, that's okay. So now we've come to this last lesson, lesson 6 on tangent function. And it says here the graph of a tangent function is equal to y equals to tan of x is a periodic function, but not sinusoidal. The word periodic means something that repeats itself every single time. There's a lot of things that are periodic function, okay, periodic. If you have taken some biology courses and here's a very typical EKG or something like that, I'm just kind of drawing it. So this is like basically one heartbeat, and then you go another heartbeat, and then another heartbeat. This one here is a periodic function, right? This is the, it repeatedly repeats itself. That's why it's periodic. Repeats itself. Every heartbeat repeats itself. So this is periodic, but not sinusoidal, because a sinusoidal looks like this. This is the one that we're used to, okay? Sinusoidal, that could be the y equals the sine function, or it also could be the y equals the cosine of x function, because we already know that a graph can be expressed as a cosine or it could be expressed as a sine. So this one is a periodic and sinusoidal. Okay, periodic and sinusoidal. So now this one we said is periodic because it repeatedly get repeated, but it's not the same wave that we are used to seeing. So why is it like this? Why is it like this? Now what do we notice here? You see this line? What do you call that?
Asymptote?
No. These are called the asymptote. So there are asymptotes on this function. And well, why do we have an asymptote?
Because it's sine over cos.
Like when we look at the rational functions before, something cannot equal to 0, right? So when we look at the asymptote, there's some number that will equal to 0. And well, what's going to equal to 0? Let's see. We know y is equals to tan of x. That's tax. Don't want tan of x. There you go. Yeah, tax. Yeah, it's a tax season. Y equals to tan of x. Well, tan of x could be expressed as y equals to sine of x over cos of x. Yes. So far so good. Right? So tan is equal to sine of x divided by cos of x. Now, because this cos of x, okay, cos of x approaches 0 at some angles. Okay, so the cos of x is 0 at some angles. Now let's see where is cos of x equal to 0? Where is cos of x equal to 0? Okay, cos of x are the x coordinate value in our unit circle. Okay, so let's go back and take a look at our unit circle. Okay, let me pull it out. Where is cos of x? And this is something that we have to memorize, and I think last time we got away without it. Okay, where is cos of x 0? I think somebody already said it, but I just want to pull it up. So this unit circle, the x coordinate is the cos of x, and then this is the sine of x. So here at 0 degrees or 0 radian, cos of 0 radian or 0 degrees is 1. So at what angle is cos 0? At pi half? Oh, nobody said 90 degrees. Okay, yeah, they're both correct. 90 degrees, okay. So it's gonna be, let's do 90 degrees. Where else? Okay, or pi half. This is, okay, they're the same. Where's the other one? 3 pi over 2? Or 270 degrees? Where else? Okay, well, maybe you can see the pattern. 1 pi over 2, 3 pi over 2. What do you think the next one is? 5 pi over 2, 7 pi over 2, and so on, right? And what about the negative part? So if you swing this way, it's going to be negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, and then so on. So there are many angles where the cos of that angle is 0, and these are the ones. So when we have, if we put pi over 2 there, okay, what would happen? Let's see. Y equals to tan of x, and y is equals to sine of x over cos of x. Pi by 2. Okay, so if our theta is pi by 2, okay, well, what's the sine of pi by 2? Sine of pi by 2 over cos of pi by 2. Sine of pi by 2 is 1, and divided by cos of pi by 2 is 0. And if that's what it is, that's going to give us undefined, and that's where the asymptote is going to be. Okay, we can get closer and closer to 0, but we can't really get to that. So, where are the asymptotes? Asymptotes are where the denominator is 0. Where the denominator is 0. Okay, and then where is the denominator 0? At what angle? It's going to be pi by half, pi by 2, pi by 3, 5 pi by half by 2, and so on. So this is where the asymptotes are, right? And that's what's true. Now we have to explain the shape of this. We've accounted for where the asymptotes are, but why is the shape like that? Right? Okay, let's see. I'm just gonna do this kind of like side by side here, and then we'll go on from there. Okay, let's see. Now, if the angle is 0, what's tan of 0? Tan of 0 is sine of 0 divided by cos of 0. It'd be 0 divided by 1 is 0, right? Now what happens over here at pi by 6? What's this? What's the tan of pi by 6? 1/2 divided by that. It's going to be 1 over root of 3. And what's 1 over root of 3? Need my calculator. What's 1 divided by root of 3? 0.5. Well, where's 0.5? So this is going to be, if this is pi, where's pi by 6? 1, 2, 3, 4. Pi by 6 would be over here, right? No, this is pi by 4. Pi by 6 would be over here. Just before the pi over 4. Just before the pi over 4. Now, what about the pi over 4? If theta is pi by 4, what's the tan of theta? 1. So it's at pi over 4, the tan is sine of x divided by cos of x, which is equals to 1. Okay. Now, what about at pi by 3? Square root of 3. Root 3 of divided by 2 divided by 1/2. When you divide that, the 2's would cancel, right? So root of 3 divided by 2 divided by 1 over a half. The 2's cancel. It's going to be root of 3. Well, what's root of 3? 1.7. So where's pi by 3 here? Pi by 3 is before the pi half. It's going to be 1.7. So it's going to be 1.7 would be somewhere right there. And now what's happening when it gets closer and closer to 0? It's an asymptote, right? So it just gets closer and closer to 0, but it won't touch it. Now what about this way? To the left side. So it's pretty much the same thing, but it's negative, right? So over here, this is going to be negative pi over 6. You okay with that? Negative.
Why do we go back instead of?
Oh yeah, so what we can do is we can, so at here, over here at pi by 2, it's undefined. We can go to this one over here. Let's see. Do you want to go this way first before moving this way? Yeah, we can do that. Now, over here, what would it be? What's the tangent of 2 pi over 3? Root 3 over 2 divided by negative 1/2.
Negative.
It's going to be negative root of 3. So where's negative root of 3? Which is over here. And then you go here, tan. Okay, over here and this side, tan C. I'm going to go here, C A S T. So here, tan is negative, right? Because the only thing that's positive here is the sign. So tan is negative in this area between pi half and pi. So that's why it's below the line. And then this one here is 3 pi by 4. 3 pi by 4 is going to be -1. And why is that -1? Yeah, where's 3 pi by 4? 1/4, 2/4, 3/4.
Because they're both roots.
They're both the same value, but one is positive, one is negative. So if you divide these two, it's going to be a -1. So that's this one right there. Where is 5 pi by 6? 5 pi by 6 is going to be 1/2 divided by -1. 1/2 divided by -√3/2. Okay, the 2's cancel. It's going to be 1/-√3. So 1/-√3 would be over here. And then let's see, pi. What's at pi? It's going to be 0 divided by -1. 0 divided by -1 is 0 divided by would be at 0. Okay. And as we are getting closer and closer to the asymptote, it's going to continue down that way, continue down, but not touching the asymptote. Okay. So this part here, okay, this part here is what quadrant are we operating here? This is quadrant 1. Which quadrant are we operating in here? Quadrant 2. Now, which quadrant are we operating in here? Quadrant 3. And then let's take a look. In quadrant 3, tangent is positive. Is that true? Yeah. Sine is negative. Cos is negative. So negative divided by a negative is going to give us a positive. So tangent is positive in quadrant 3. So this is quadrant 1. These are the points on quadrant 1. These are the points in quadrant 2. And which one is this?
4.
Quadrant number 4. And are you okay with this being down below? Yeah, because in quadrant 4, tangent is negative.
And that's why you went backwards when you wanted to look at the other one.
Yeah, and then if I go this way, if we turn negative rotation, negative angle, it's clockwise here. The tangent here is positive. No, tangent here is negative. So it's this way. So this is the negative angle, but quadrant 4. What about this one?
Quadrant 3.
This is going to be quadrant 3, but turning to the negative angle. Negative rotation, negative angle. Now you're on quadrant. I'll put that in there. Quadrant 4. This one is quadrant 3. No, it's this one. This is going to be quadrant 2. And then this one is back to 1, quadrant 1. That's after you. If you turn negative angle, quadrant 1, it's going to be positive. Okay. So let's see if we can put it together. We did put it together, right? So when we first y equals the tangent of x. Well, that's great, but I think it's better if we write it this way. Sine of x over cos of x, because we can write tangent as a function of sine and cos. And then what's here? What will make the denominator 0? That's where the asymptotes are. Okay, so where is cos of x equal to 0? Pi halves, 3 pi halves, 5 pi halves, and so on. Negative pi halves, negative 3 pi halves, negative 5 pi halves. So if this is pi, 2 pi, negative pi, negative 2 pi. So this is where the asymptotes are going to be. Pi halves, three pi halves. Okay, make sure you put an arrow in asymptote.
Are we only dealing with horizontal asymptotes?
Now, horizontal asymptote. Let's finish this up and then we'll talk about any horizontal asymptote here. Okay, and then here it's going to be like this. Okay. Now, are there any horizontal asymptotes in here? Are there any horizontal asymptotes? No. Okay. There's no horizontal asymptote. As you can see, there can't be a horizontal asymptote because this is going to extend infinitely up and infinitely going down. And when do we have a horizontal asymptote? When the denominator is way bigger than the numerator. And in this case,
Never?
there will never, yeah. Because when you look at this, sine is going to be between 0 and 1, yeah, right? And then this one is going to be, cos of x is going to be 0 and 1. So nothing will get way too much, way too big for this to be 0. Okay, that's awesome. What's the x-intercept? You'll probably say there's a lot of them, right? There's 0, pi, 2 pi. What do you think the next one is? 3 pi, 4 pi, and so on. Okay. Why is that? Because if you divide, where is it going to be 0 when it's 0 divided by 1? 0 divided by negative 1. So this is 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. Okay. And then negative pi, negative 2 pi. So there are infinitely many x-intercept, and then I have to go like this. I have to make it. What's the y-intercept?
Here?
Y-intercept is at 0. Yeah. Good. Now let's take a look at characteristics of tan of x. What's the period? When does it repeat itself?
Pi?
So it repeats every single pi, right? So here, pi. It repeats itself every single pi radians. What are the equations of the asymptotes? Okay, we've kind of discussed that already. In this case, it's going to be negative, I'll start with 1. Pi over 2, 3 pi over 2, 5 pi over 2, and then negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, Now, can we generalize this? Because there's going to be infinitely many possibilities. So how can we generalize the equation?
That one usually like 0 plus pi and then k.
Yeah, we're going to have like the k thing, right? It's going to
Infinity.
So you can say equation of the asymptotes. Okay, equation of the asymptotes is pi halves plus, okay, this is going to be, the next one would be pi, sorry you can't see that, the next one is another pi, right, pi halves, and then another, it repeats itself every pi, so pi times k, where k is an element of the integer. That's the general form. So if you put 1 here, okay, let's try that. Let's put 1 for k. If this is 1, what would it be? What would be the next one? If k is 1. Pi halves plus pi times 1, what would it be? Pi halves plus pi times 2 to make the same denominator. It's going to be pi halves plus 2 pi halves is equals to 3 pi halves. 3 pi halves. What if k is 2? Pi halves plus pi times 2. That's going to give us pi over 2 plus 2 pi. We're going to have to multiply by 2. That's going to be 4 plus 1. So it's going to be 5 pi halves. 5 pi halves. And then so on. And if you go to the negative one, let's see negative 1. Pi halves plus pi times negative 1. Okay. Well, we can't subtract these two unless they have the same denominator. So I'm going to multiply by 2 halves. This is going to be pi halves minus 2 pi halves. Negative 2, positive 1 is negative pi halves. Negative pi halves. Okay. Any questions there? So period is pi, because it repeats itself pi radians. And then range. What's the range? What are the possible y values? Y values. Yeah. Negative infinity up to positive infinity. Or we can say y is an element of real numbers. What's a y-intercept?
0.
0, yeah. Talked about that already. What's the x-intercept? X-intercepts are 0, 0, and then what's the next one? Pi. What's the next one? 2 pi. What's the next one? 3 pi. Well, that's too many. 3 pi. And then dot, dot, dot. What about to the left? What would it be? Negative pi. Next one.
Negative 2.
Negative 2 pi. Dot, 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 right? Can we generalize that?
We
Okay.
do it the same way as the
Can we
equation.
see? Well, we gotta have some starting point. 0 radians. What do you think that is? The next. Plus
Pi
pi
times k,
times k,
where k is an element.
where k is an element of an integer. Test it out. So if you start at 0 and you put in a plus 1 there, would you get pi? Yeah, right? If you put 2 times pi, 2 pi. If you put 3 times pi. What about negative 1? Or we can say, or you can just say pi times k, because you're adding a 0, right?
But just in case it didn't start at 0.
Yeah, sometimes there's a phase shift, and yeah. In this case, it does start at 0. Yeah. Okay, so notes here, special notes, the function of y equals to tan of x has no maximum or minimum values because it's going to go positive infinity to the negative infinity. And the locations of the asymptotes is where the tan is undefined on the unit circle. Okay, whereas its cos of x cannot equal to 0. Okay, well that's the end of that. So we've pretty much finished discussing the lesson 6, which is graph of a tangent function. I hope that makes sense with this graph in here.
Did you announce when the test is yet or no?
Yes, we